Welcome to the Analytics Engineering Podcast, featuring conversations with practitioners inventing the future of analytics engineering.
This week is one of our favorite weeks of the year because it's COALESCE. COALESCE is DBT Labs' annual online data conference dedicated to the advancement and practice of analytics engineering. We have nearly 100 speakers giving talks across 5 days, and this year we have more than 10,000 attendees. We're broadcasting a few talks in the podcast so that our listeners don't miss out on the great content. We are about to listen to DBT Labs co-founder and chief product officer, Drew Banin, speak with Databricks' co-founder and chief architect, Reynold Xin. They're going to speak about the state of warehouses, or lakehouses, as Databricks has coined it, and what's going on with the storage and compute layer of data infrastructure. Lots of important trends discussed in this one, so let's hit play.
Reynold, thank you so much for being here with us today. Really appreciate you joining.
And really happy to be here.
Just because Spark has been so influential and you've played such a big role in it, can you tell us a little bit about your background working on Spark and sort of how that started and what shape it's taken over the years?
Yeah. So this is actually a fairly interesting story that a lot of people don't know about Spark itself. Most people knew it started at UC Berkeley as a research project, and over the years have taken to over the world. But initially, it had a very, very humble beginning. It had to do with the $1 million, which is the Netflix prize. So back in 2009, 2010, Netflix had this Netflix prize competition. And the idea is it's incredibly important for Netflix to understand what movies people would like watching. So they can procure those movies, they eventually produce those movies. Like Stranger Things, I think Amy mentioned on the Slack channel. So they did this open competition by sort of anonymizing all the movie rating data sets and then ask anybody in the world can participate. You can get a handle on the data set and come up with a better machine learning model than their baseline. And whoever they would come up with the best model would win. Lester was one of the students at the UC Berkeley AMP Lab, and he was a very competitive person. And plus, as a PhD student back in Berkeley, he was making $2,000 a month. And the competition as award amount was actually $1 million. So Lester really wanted to compete. But he ran into a big problem, which is it was a pretty sizable data set. He didn't have the tools to transform them, and he didn't have the tools to express the machine learning algorithms on them. Like, it wouldn't work on MATLAB or sort of like a single node Python program. So he talked to Matei, who at the time was a sort of systems PhD student, and said, "Hey, why don't you help me build some too, and I can win the prize. We can split some money together." That's actually how Spark was born. The first version of it was dedicated specifically to this task of, hey, given a bunch of data that's pretty sizable, how do we process it, get it into a shape that's ready for building machine learning models, and then how do we build machine learning models quickly out of it? It was only 600 lines of code, very, very simple. Obviously it started as more and more people realized, hey, it seemed like the ability to handle larger amount of data quickly and being able to iterate quickly is pretty important. It's not just something that maybe a PhD trying to work on a Netflix prize would want. So everything just happened from there. I joined the project sort of about a year later. That's when I got to Berkeley. At first, I actually didn't work on this side of the house. And then over the years, I was more like I specialized in databases, data warehousing, and I brought a lot of the, I would say, sort of classic database ideas and implementations into the Spark ecosystem. So kind of marry they started with a very strong roots on like how do we do massive parallelization to handle machine learning data. And then over the years, I brought a lot of, so how do we just process data in general, leveraging sort of 3 or 4 decades of database knowledge the industry and academia have developed.
That's an incredible story. What was the state of the art back in like 2009, 2010, if say, parallel universe Spark wasn't invented? How would folks do it back then?
Yeah, so I think it was incredibly difficult. There are kind of 2 camps. There's the data warehouse camp, which you could dump all the data in, and it kind of runs dashboarding. Like even back in 2009, 2010, you could probably run dashboards pretty well, and for business data. And then there's a Hadoop camp, which is the big data camp, And the big data camp has one incredible improvement over the data warehouse camp, which is you could dump anything you want into it. And it's super cheap relatively. But it was almost impossible to do anything. Like if you want to write a MapReduce program to just run a very simple query, you have to write like tens of thousands of lines of code.
Yeah.
Right? It's impossible to do anything. And that's where I think the world got stuck.
Yeah. Was that like Pig back then? Was that the state of the art? Did that come later?
Pig, Hive was like just getting out the door.
Right.
And I mean, very few people use Hive anymore, and nobody's using Pig anymore. There's a lot of tools that were invented, so trying to tackle low-hanging fruits, and over the years, most of them become irrelevant now. But it's definitely it's a very different time from now.
Okay, so I mean, Spark has surely evolved an incredible amount since that original Netflix challenge. But this concept.
Oh, by the way, Joe, and some audience might be curious, what the hell happened to the Netflix challenge?
Oh yeah, of course.
Didn't win. He got the model roughly 10% point better than the baseline model, which is a massive deal for a machine learning algorithm. And he tied for number one with somebody else, but then his entry was submitted 20 minutes late. So he lost $1 million. So if Spark were invented 20 minutes earlier, Lester would have been $1 million richer.
That's pretty incredible. It just speaks to the importance of performance and interactive query response time. Getting those results back the timely manner.
Absolutely.
Yeah, great. So the fundamental thing there you touched on was like the idea of unstructured or semi-structured data kind of like living in this data lake and being accessible for analytics. So I'll just say when we started building DBT, it was on more traditional data warehouses, and it was probably late maybe 2018 or 2019 when we first started investigating integrating DBT with Spark. And back then, I think it was just vanilla Spark we started with. Today is kind of a momentous day because you and the folks at Databricks have something to announce. Is that right? Absolutely.
So I think the announcement actually went out very early this morning. There's the new DBT Databricks adapter that we have actually worked together on, DBT Labs and Databricks. And it's a big deal in our mind because it's it signals a very strong intention to collaborate here and then actually create one of the best, I think, ways to run DBT on Databricks. And it's not just an adapter. Like it's not just, hey, we built another connector and so what. We have actually, it sort of also signals the beginning of us looking at, hey, what are the type of queries DBT generating? How can the platform actually run those queries better once we've gotten those queries onto Databricks? As we're talking just off stage right now, our team that works on the core engine actually look at the type of queries that were generated and optimize for that specific pattern. And the incremental data load of queries would run actually 8 times faster in the next release of the Databricks platform, which customers don't have to do anything to. They'll just get automatically updated.
Yeah. That kind of integration is really, really exciting. Certainly to us and the folks that use DBT on Databricks. You mentioned the incremental kind of approach. Is it the merge statement in particular that gets the speed up or something else?
I have to look into the details of it, but I think it's actually I'm actually pulling up the query here right now. I think there's a very, very long query that gets generated. It's about use decimal, and it's like 3 pages long with like an MD5 expression in it. I personally don't understand the queries that's generated a lot, right? But it's actually the specific combination of expressions for that that would I think actually could be optimized a lot better.
Sure. Okay. Well, that's a really powerful thing for folks to.
So it's not. I don't think it's for merge. It's for the just incremental getting data with maybe a marker of, hey, this is the latest data that's been coming in, and more data can come in the future.
Got it. Okay. So it's really cool to hear things like that, because back in 2019, I remember very well trying to integrate DBT with Spark, and there's a lot missing. Like we were trying to build the incremental paradigm, and we were working with vanilla Spark back then, and it just was not a great experience to spin up clusters, and it's sort of like missing the data catalog that DBT needed to generate its queries. But a lot of that's changed in the past couple of years, and specifically around the work that you're doing in Databricks. Can you give us like a little bit of a survey of how the thinking has changed inside of Databricks from maybe who you were building for 2 or 3 years ago versus like what kinds of use cases you're thinking about today?
Yeah, absolutely. I will. So it actually in many ways mirrors the Spark journey, which is, and by the way, I think what you said earlier is dbt actually grew out of necessity, very similar to Spark, right? There was a concrete problem that they didn't have good solutions to. And so Matei and Leslie invented Spark together through that. And I think in your case, you had a concrete problem probably was, hey, with the new term, I'm an analyst engineer, and none of this modern data stack existed. I want to bring maybe rigor to my sort of data pipelines or data engineering jobs. I want to make sure things are correct. I want to make sure I can test them. I want to make sure I can sort of roll things out in a way that's safe. And those are kind of the software engineering principles I would say software engineers deal with all the time. But once you get to data, it becomes very ad hoc. It's not clear what the standard way is. And you guys kind of created a way to do this. And it's actually with concepts that are very much familiar with a lot of the data analysts that just are using SQL. I think that's a big deal. So maybe before I go into Databricks, sorry,
well,
I'm pretty excited about DBT stuff. So
right. Well, one thing on the topic of necessity and DBT, we started the company 5.5 years ago, almost, as a consultancy. And the really funny thing was we worked on sort of like sprints. So there was no time-based contracts. It was all based on like work delivered. And so the sort of equivalent to the Netflix challenge for $1 million was like a $3,000 statement of work to deliver marketing attribution in 2 weeks for us. So like different kinds of stakes at play there. But it was the same necessity of we wanted to do this work. We wanted to know that it was reliable. We wanted to understand what had changed at what point in time because we were working with different clients and kind of different kinds of engagements. And so very much like the thing we built in DBT came out of that environment of wanting to make analytics more repeatable and sort of like scrutable in a way.
So by the way, I see a lot of great products and projects evolve this way, which is so the creators of the project had some concrete problems they had to solve, and then it turned out the concrete problem is shared by everybody in the world and in that regard, so Spark, Databricks, DBT share very common roots. All right, so now coming to the how are the workloads evolving on top of Databricks and Spark? So initially, I think there's a lot of the workloads on Databricks and Apache Spark project primarily target, I would say, two sort of orthogonal dimensions. One is the users of the product or projects tend to be fairly technical in the sense that they're writing Scala code, they're writing Python code, they might be writing R code. And a lot less of them were actually using like vanilla SQL. The other dimension is there's a lot of focus because of the root of the project, which talked about was invented to build machine learning models. There's a lot of focus on data science and machine learning. So a lot of the Databricks workload initially were focusing on those. And by the way, but as part of data science and machine learning, obviously you have the whole job of data science and machine learning is not only about building models. A lot of it is about cleaning data, getting data into the right shape or the right form. So if you look under the hood, they're very similar to the type of data transformations you'll be doing in data warehouses. But the way you express them is very different. So the actual job is very different. And then over the course of, I would say, the past 2 or 3 years, we've noticed we always had some SQL support. Because as I said, hey, it's actually the core operations under the hood are very similar. Like a join is a join. It doesn't matter if you're using Python, using like SQL. You're joining data under the hood. So we always supported SQL, but we didn't invest massively in it. But then over the course of the last 2 or 3 years, we noticed, hey, our SQL usage is growing organically very, very fast. As a matter of fact, faster than pretty much any of the other programming languages. And then we started interviewing customers and trying to understand why and what's going on. And many of them told us a consistent message, which is, hey, I'm already building my data engineering pipelines and doing a lot of data science on this, and a lot of data are produced by Databricks. And typically we ETL a subset of it that we consider more business aggregates into a data warehouse. But then inevitably, some analysts come back and say, hey, I want access to that raw dimension of data, or I need that attribute that hasn't been ETL yet. So we're faced with a very sort of a dilemma. Do we disrupt our sort of backlog, which could be 6 months or a year long, to create a new pipeline to ETL that? Or do we just give customers, like our customers, which is our customers' customers, the analysts, access directly to Databricks and run through SQL, even though we know SQL on Databricks didn't work that well. So many actually ended up slowly giving more and more access. And that's how it organically happened. And then we started looking at the problem a lot more, and we felt, hey, if there's already a clear desire here from our customers, despite us not pushing for it, maybe we should actually look into investing heavily. So for the past 2 or 3 years, we've spent massive amount of, or reoriented almost the entire company to look at, hey, how can we actually deliver really good SQL experience on this massive amount of data in the data lakes that are already produced by Databricks. And I would say we kind of left no stone untouched. So going from all the way at the bottom of stack, like how do we launch compute in less than a second, to, hey, how do we rewrite our actual execution engine to be able to process data much faster for specific the SQL type of workloads, and all the way to the UI. It's like, how do we create a SQL editor that, like when analysts comes in, they feel like, oh, this is like a very similar tool from everything else I've used before.
Yeah, got it.
Yeah, I'm happy to get into more details in any of that, but I don't know if we have time. It's up to you then.
Yeah, let's go one layer deeper. I understand that you were a driving force behind like the creation of data frames in Spark. Is that right?
Yeah.
So
I think I wrote most of the initial code and the design doc on it.
Perfect. So,
but to be clear, Spark is a massive open source project with thousands of people contributing code. I can't claim all of the credit, but I wrote like the first maybe few hundred lines of code that define the data frame API.
Yeah. So as the originator of the data frame in Spark, when it's time to do an analysis, do you reach for like Scala or similar, or is it SQL these days?
I would do both. And I think it's actually important to have both. The reason is they're very different persona, and there are different jobs to be done. I think SQL is incredibly powerful, and probably if you just count by the number of like individuals you'll be using, SQL by far eclipse like Python, Scala. But from the perspective of, I think a lot, what we do see a lot is, because we're coming from a totally different perspective, is a lot of the workloads, they are not, they don't fit that well into like traditional data warehouses, and people sometimes try to shoehorn them in, but they don't work that well. Like when you have something extremely complicated that would actually take maybe a couple thousand lines of Python to express, which a lot of data cleaning workloads, domain-specific applications do, it becomes incredibly awkward to express all that in SQL. So we think different, and by the way, and many of those are some of the most compute-heavy workloads, and also are some of the most important of business workloads because they move the needle so much. So I think having both is actually pretty important. And we're seeing sort of the world also now converging towards that, right? Which is even in the past few years, every sort of traditional data warehouse is trying to bolt on some sort of additional programming language beyond SQL.
Sure. So, it's an interesting kind of arc. You talked about how maybe earlier in the Spark lifecycle, you'd see folks do a lot of ETL work in Databricks, maybe load it into a more traditional warehouse, and that was used for BI. And you're kind of saying that these days that's changing. And so there's kind of two things to talk about. And the first one I want to talk about is we've seen a big proliferation of different databases for different use cases.
Yeah.
And I think the title of this session is you don't need another database, right? So can you tell us a little bit about where you're coming from in that arc, and what you think the future looks like if it's fewer or more databases fundamentally?
Yeah, I think the world will slowly go towards consolidation. And the reason is for data workloads, at the end of the day, data is the common shared asset. And having multiple systems, it is true that if you specialize for any particular workload, you might be able to make progress much sooner, and be able to support that type of workload, especially in performance, much better. But in practice, there's an extremely high cost of having to run a lot of different systems. There's extremely high cost to maintain them because I think one of our customers, Emmons, recently was interviewed and they talked about this issue, which is, hey, if I run two different systems with the same copy of data, in practice, they're not the same because access control might be different. They might not be perfectly synchronized. And then I have different consumers of that data coming up with similar metrics or same definition of the metric, but with different result. And then sooner or later, so the rest of the organization stop trusting the data because they don't know which one is correct. And that is a huge issue, I see. So I think over time, while I definitely can see the appeal of, hey, I need for example, graph database, or hey, I need a data warehouse specifically for serving BI workloads. I think over time, we'll sort of converge on, hey, there's fewer copy of the data, and most likely here's one copy of the data, and there are extremely niche cases that really nothing else could satisfy, and it's so important. And I'm always going to create like some special thing on the side to support.
Yeah. So Martina and Tristan touched on this a little bit this morning in terms of the data space and its analogs with sort of the application development space. And if you're building an application, it's reasonable to have Redis and Postgres and maybe some sort of a key value database. But I guess I'm wondering how to translate that into the data world. Does it look more like centralized compute with different types of like data applications on top of it, or like how do you think about that convergence happening?
I think the most likely way, and we're seeing it actually happening slowly in a lot of the larger enterprises, and but I think a lot of it's actually driven by maybe the fan companies early on. They kind of figured, like in terms of tech, right? It's not true that you can just take whatever Google built internally and actually have the rest of the world use it. But if you look at the high level, like 20,000 feet level, it's actually decent, maybe sort of view of, hey, what the future might go. If you look at Google, Facebook, Microsoft, Amazon, all of this, and Netflix, all of this like top companies, the way they do it is, hey, let's create. They might not actually call it a data lake. It's like, here's a repository of data. In Google case, it's like COALESCE, a file system. But if you look at it, it's just a data lake, and you dump all of your data in it. It doesn't matter what it is, and then we have open spec to define what are the storage, and then you can actually create different maybe engines for processing them on top. Like in the case of Google, they have F1 for serving pretty much all of the queries, and added like this new system called Napa for serving materialized views. But then you have like all of the systems that sit on top of the open data lake. And in the case of Facebook, they use Presto and Spark and they use Spark for a lot of ETL and a lot of the maybe longer running SQL, and Presto for the interactive SQL. And basically, they created this architecture that we call the lakehouse, which is you store all of the data in data lakes, and then you run all of your workloads just against the data lake. And from by the way, there are still organizational issues, politics you have to solve in the organization, just like everything else. But from a tech point of view, all of this companies standardize on, okay, here's the more or less the lakehouse architecture, which is you dump all the data in the data lake with open format, open spec. And then you have different workloads running on top. Okay.
Yeah, it certainly feels like a compelling model to be able to, just from a governance perspective, manage all that data and who has access to it. And
I think governance it's extremely important because it substantially simplifies what you have to think about if you have one place to look at.
Sure. I must tell you, I am peeking at the Slack channel, and there's one question that I do want to bubble up to here, and we can certainly answer others kind of in the chat. But the one big one here is from Josh Devlin, and he says he doesn't have that much experience with Databricks, instead focusing more on traditional warehousing options. And he's wondering what the case is for choosing Databricks over some of the other leading data warehouses on the market today. How would you argue for Databricks in that question?
I think the good way to think about it is Databricks is started on the more data processing side, and then focus a lot on data science and machine learning. And we are now I would say taking on what we call the lakehouse architecture, which is, hey, you should be able to run all workloads on Databricks. Now, specifically when it comes to the data warehousing style workloads, a lot of what I think in the past that didn't run so well, I think Drew, you talked about is, hey, there is a lack of maybe a catalog. There's a lack of sort of a low latency queries for BI. We're working on a lot of those, and you can actually find a lot of benchmarks. I think we have state of the art, the performance in a lot. As a matter of fact, we just won the TPCDS official benchmark #1 result in the world for ability to process the complex SQL queries super fast. There's actually ways to do governance. You could do fine-grained access control on all of your data. So that's what we worked on a lot in the past couple of years. Now, if you think about it for maybe the consolidation layer, what advantage you would get is you get basically a single layer that can actually serve the data warehousing workloads, as well as the machine learning and the data science workloads. They are becoming increasingly more and more important. You can run workloads from super small scale to super large scale. And I think probably look at it more closely. There's really only one platform right now on the planet that could effectively do so all of these workloads on one platform.
It's a strong argument. I'll tell you, we are impressed and grateful overall for the sort of pace of innovation and development in the data warehousing space. And just broadly, I'll tell you, we totally see the sort of convergence that you're talking about. And it's happening in different ways in different places, but it could look like AI or sort of data science capabilities in some data warehouses, or more like other languages and others. Support for other languages and other data warehouses too. So it's really an exciting time to be following along. I guess kind of coming up on the end here, and then we can jump into the Slack to kind of discuss with others. I do want to take a moment to get a hot take out of you. There's a lot of hype in general around the sort of modern data ecosystem. What, in your opinion, is overhyped right now?
I think most things are, I think the modern data stack is actually solving some really concrete, real problems, and we're really excited to be part of that. There are a lot of individual concepts that might be overhyped. I think, for example, data ops. I think people have been doing that for a long time, and people are trying to do that. And I think tying back to what we talked about earlier is whether you need another database or not. I think a lot of domain special databases are probably very much overhyped. Just because Facebook had to build something to serve their traffic in specific ways doesn't mean you have that problem. Most problems, when they are not as specialized, not as large scale, you can perfectly solve it by just using sort of an existing implementation. And then it actually goes back to the point of consolidation. It doesn't bring you that much good to bring a lot of specialized systems everywhere. Okay,
great. I will tell you, I read a white paper out of Google on a database called Procella. And if I ever get a couple months off, I want to go implement it. And it is a little like, wow, Google's doing it. So
one of the main tech lead of that project actually works at Databricks on the Databricks SQL right now.
That's awesome.
And he's trying to not create a specialized system, but instead a more general one. He's just trying to improve the general infrastructure so we can do super low latency queries.
So if you're able to share the inside scoop, is it as cool as the white paper makes it sound?
I think for the problem is solved. Procella is really, really cool. Yeah. But the problem is, hey, it's yet another system. And they have like a whole team operating it, building it, which I don't think it's very realistic for every other company to be doing. Like if you have tens of billions of dollars of revenue hinging on that one thing, yeah, absolutely, go build it. But I don't know how many enterprises would actually have that problem with will have a $10 billion product, depending on this one system.
Okay, well, that's about all the time we have together today. Reynold, thank you so much for joining me. And if folks wanted to kind of follow up with you, see what's on your mind, where can they find you out on the internet?
I'm on Twitter. I'm on LinkedIn. If you just search for my name, you'll find me easily. I'm also on the DBT Slack channel, so you can certainly. I'll be looking through the questions if we have any in the Slack channel for the Databricks specific one.
Sounds great. Thanks a lot, Reynold.
All right. It was nice chatting with you, Drew.
Likewise.
The Analytics Engineering Podcast is sponsored by DBT Labs and is hosted by Tristan Handy and myself, Julia Schottenstein. Have comments, questions, or guest suggestions? email us at podcast@dbtlabs.com. Our producers are Jeff Fox and David Krevitt. If you enjoy the show, please drop a review or share it with a friend. Thanks for listening.